All right, we'll go ahead and get started. Um, if you haven't checked in, please do that. That needs to happen. In one word on checking in, usually when I have a question there, uh, if you just write here, that's not helping me at all. That's also not helping you or your class at all. If you don't have any questions, just say none or no questions or I understand it. But if you do have a question, give a specific example. And if you need to email me that after you check in, that's totally fine. The more specific the question, the better. If it's a general question like I don't understand this or I can't get past a certain number, it's really not helpful. I understand that you're frustrated with it, but the better and more specific a question, the more that I can help you. Okay, so not being able to get past like 80, that's for the most part you understand the content. You're just getting tripped up by more difficult equations and algebraic stuff. Um, Again, the more specific the question, the better that's going to help me, the better that's going to help you. All right, especially in this context, right? I can't see exactly where your problem is, um, but if you are able to kind of define that on your own and submit that as a question, I am definitely going to help you, and that might help a whole lot of other people here too. Okay, so keep that in mind. You please answer the prompt in um, on campus. That's It's not just an attendance thing. It's so I can gauge where your understanding is. Okay. Today I want to do a couple things. I want to maybe address like a, a question or two from the homework last night. It didn't seem like there were many specific questions or um, general concepts. Uh, so I'll look through that again real quick. But after that, I want to go over a specific type of sequence, and that's called arithmetic sequences, which you can see on your screen. Um, if you want to, I would start maybe writing this so we can kind of catch up. I'll look through the questions one more time, and if there's any ones I can specifically answer, I will do that. Otherwise, we'll just go over this. Okay. After we go over arithmetic sequences and what they mean, we'll go over their rules and their sums. Okay, then we'll go over a couple of examples, and then you guys can get started on your homework. Okay. Um, yeah. So let me go over the questions in on campus, and we'll go over any that we can. Otherwise, if you don't have any questions or you're not worried about anything, I would start writing this down. All right, so I'm going to try and address some of these maybe a little bit more simply than what you can see on IXL. Um, but up here we have the sum from I equals 3 to I equals 5 of 5i plus 2. Okay. Uh, One, this is finite, right? Neither of the limits are infinity, so this has to be a finite sum. Okay. How many terms are there? Well, there's the third term, the fourth term, and the fifth term, right? So if we write those out, that's 5 times 3 plus 2 plus 5 times 4 plus 2 plus 5 times 5 plus 2. Okay, so total there are 3 terms. Okay, so that's like the simpler question. When you get a sequence of numbers, the trick is finding the rule. And I don't want to go over how to do that necessarily right now. If you go back in previous lectures, they're there. And then there are also examples in your textbook. Okay, but I will say that there's no one specific way on how to do it. If there's a fraction, normally I look at the numerator and denominator, and then you just gotta kind of see how you get from the number of the sequence to the actual number itself. Okay, and then there's a pattern. The trick here is finding the pattern, which can be very, very difficult sometimes. Okay, again, it takes practice, and we can go over that a little bit later. But for now, let's just understand this summation notation type stuff. Okay, um, so let's move to arithmetic sequences, and we're gonna start talking about specific sequences. Okay, so yes, there are infinite and finite sequences, but there are also like different subsets of those groups. And one of them is arithmetic, and this is probably the simplest type of sequence. And what arithmetic sequence means, what that actually is that in order to get from the first term to the second term, you're just adding a certain number. And then you're adding that number over and over to get other terms in the sequence. Okay, so if we have each term, so the first, second, third, fourth, all the way up to the nth, and even past that, the difference between sequential terms, right? So a2 minus a1, that's going to equal a3 minus a2, which is going to equal a4 minus a3, which is going to equal an and minus the term right before that. Okay, that number is constant all the way throughout the sequence. Okay, and that specific number we'll call d, which is called the common difference. So again, all that an arithmetic sequence is a sequence of numbers who has a common difference between them. So I have two sequences written down below, right? And we'll start with the first one. And the first thing that we need to be able to do when we're talking about types of sequences is just one, get a pattern pretty quickly, and two, classify it as arithmetic or any other sequence we're talking about. Right now it should be easy because we're only talking about arithmetic. So is it arithmetic or is it not? Okay, so this first sequence, 2, -3, -8, -13. In order to establish whether or not it is an arithmetic sequence, we can take the difference between each one. Right, so -3 minus 2, that's -5. -8 minus a -3, again, that's -5. And then -13 minus a -8, again, that's going to be -5. Because these differences are all constant, we know we have an arithmetic sequence. And the common difference would be that constant term. So in this case, d is equal to -5. Okay, so right now all we need to be able to do is just tell whether or not it's arithmetic. And then find the common difference. In the second sequence, 1, 4, 9, 16, again, we can see if it's arithmetic or not just by taking the difference between sequential terms. So 4 minus 1, that's equal to 3. 9 minus 4, that's equal to 5. And we can stop there because that's not equal to the first difference. Because these two things aren't constant, they're not the same, it cannot be an arithmetic sequence. So I want to pause there for a second. Are there any questions over what you see so far? And when we're talking about arithmetic sequences, there are certain rules that we can establish right off the bat. As soon as we know it's arithmetic, these rules apply. The first is just finding the nth term of that sequence. Okay, so to find the nth term of an arithmetic sequence, we have the first term plus n minus 1, so the number of the term minus 1, times d, the common difference. Okay, and this is very important, so we definitely need to know this equation. All right, and that's how you find the nth term. So on your homework last night, some people were probably struggling with that 80-ish to 100 range because you had to find the rule for the sequence. This makes it a whole lot easier if you know it's arithmetic. So for example, we want to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Okay, so we know A1 and we know D. Okay, so if we were to write this sequence, we're just adding 3 over and over again. Right, so the second term would be 5, the third term would be 8, 11, 14, 17, and so on. Right, so we're just adding 3 over and over again. But we're not just trying to find the sequence, we're trying to find the rule for the sequence. So then we plug it into the equation that we just went over. So an will equal the first term 2 plus n minus 1 times d, which is 3. And then if we simplify that a little bit, our rule, our nth term, is -1 plus 3n. So again, I want to pause there for a second. Are there any questions over anything you see so far? And different questions can be asked. All right. So in that last example, we were given explicitly that our common difference is 3 and our first term is 2. So all we really have to do is plug into an equation and then simplify, and we have our answer. Okay. But different questions can be asked. So the fourth term, so in this example, the fourth term of an arithmetic sequence is 20 and the 13th term is 65. So A4 is 20, A13 is 65. And we want to find the nth term. So we want to find the rule, and then after we find the rule, we can find the 11th. Now we can use what we know about arithmetic sequences in order to do this. Okay, so we know in an arithmetic sequence, we're just adding something over and over and over again. Okay, and we have the 13th term and the 4th term. So if we just put that on a number line, in order to get from the 4th term to the 13th term, we have to add something, the same thing, over and over again, 9 different times. Okay, so we're going to be adding something 9 times in order to get it from 20 to 65. So then we can take the difference of 65 and 20 to get 45. And then we can take that and divide that by 9. To get our common difference. So again, I'm going to stop there for a second. Are there any questions over how I got that? Okay, so we still haven't answered the question though. We haven't found the nth term and we haven't found uh, the 11th term. Okay, but we do have a common difference now, which is a good starting point. Okay, from our equation though, we need the first term and we have our common difference. So now we need to find the first term. And in order to do that, we have to keep in mind from where we started our lowest term, that's 20, right? And if we subtract 5 from that, we get our third term. Subtract 5 from that, we get our second term. And subtract 5 from that, we get our first term. And now we can find a rule. All right, so our nth term will equal our first term plus n minus 1 times 5. And then we can simplify that. And we found our nth term. And then finding the 11th term is really simple. We just plug in 11. And then we're done. Okay, so again, questions about this example? All right, and then the second kind of rule for arithmetic sequences is to find the sum of that sequence. All right, so the sum of any arithmetic sequence can be written as Sn, so the nth partial sum, is equal to the number of terms you're summing, and this is important because some people get tripped up on this. So n on the right-hand side is the number of terms being added. It is not necessarily the lower limit, which you will see here in a second. So the number of terms added divided by 2 times the first term plus the last term. And what this is really doing, and you don't necessarily have to understand this reasoning behind it, but it is averaging every value, and then it's multiplying that by the number of times, the number of terms you're adding. Okay, and because it's arithmetic, you can do that. Now, you don't need to necessarily totally understand it, but that's what's actually happening. Okay, and again, this equation is very important. So for example, we want to find the 150th partial sum of the sequence given. So in order to write that, we're finding S 150. And we already know the number of terms is 150 because we're starting with A1. And we know the first term, that's 5. Okay, so that's kind of the easy part. The next step, though, is finding the 150th term. And in order to do that, we actually need to find the rule for the sequence. Now we know it's arithmetic, so we know there's a common difference. And that common difference is just the difference between two sequential terms, which in this case happens to be 11. So then we can write a rule for the equation. And once we have that rule, we can plug in 150 for the 150th term. To get in 1644. So now we have our 150th term, we have our first term, and we have the number of terms we're actually solving for. Okay, so we just plug all that into our equation and get a number. And when we do that, we get 123,675. So if we were to add up that sequence for 150 terms, we would get 123,675. So again, I want to stop there. Are there any questions about what I just did? All right. So on your homework, you will see something that looks like this. All right. And again, your homework, not again for the first time, your homework is W11, and it goes over exactly what you will see right here. All right. given our equation, we have to find this sum. Okay, so we have to interpret this in order to put into our equation. Okay, so the first thing we do is just find the number of terms we're dealing with. In this case, it's easy because we're going from the first term to the 16th term. So total, there are 16 terms. Now, if this number instead of 1 was like -1 or -2, we'd have to stop and think about that for a second. We know from 1 to 16 there are 16 terms, so then we have to add 1, 2, and 3. Okay, so it'd be 19 terms instead. Okay, so that lower limit matters, and you have to pay attention to it. And it's not necessarily just subtracting 16 in the lower term. We have to think about how many terms are actually being used. Okay, but for the sake of this problem, it's just 1 to 16. And then after we have that, we need to find the first term and the last term, which we can do because we're given this rule in here. So A1, the first term, is 4 times 1 minus 3, which in this case is just 1. And then A16 is 4 times 16 minus 3, which ends up being 61. And then again, we can plug that into a calculator and get an answer. And our answer would be 496. Questions on this problem? And before you start that homework, again, I want to just direct your attention to this lower limit. That really does matter. Okay, so not all of your lower limits will start at 1. Some will start at 0. Some will start at 4. Some will 5. Some might be negative. And you have to pay attention to how many terms it takes to get from the lower limit to the upper limit. Okay, and if you're able to get that and this equation, then it should be very, very easy. If you ignore that lower limit, it'll be difficult. Okay, and I want to do one example that's a little bit more real world-esque, okay, and why this stuff is so important and can be really, really powerful if you know how to use it. Okay, so for example, the starting salary for an accountant is $43,800 with a guaranteed increase of $19.50 a year. Okay, and we want to determine the salary during the 5th year. We want to find the amount after n years, and then the total compensation for 5 full years. And I'm actually going to start at this middle part because that will let us answer the first one and even the last one. Okay, so we know that this is arithmetic because we're just adding 1950 a bunch of times over and over again. And our first term is $43,800. Okay, so AN is our first term plus n minus 1 times our common difference, in this case 1950. Okay, and that's really it. You could simplify that a little bit if you wanted to, but that in general is the rule for this arithmetic sequence. And then for this first part, we can just plug in 5. And when we do that, we get $51,600. So that would be the salary after 5 years. And then say you're trying to maybe save up for like a down payment on something or a house or whatever, and you want to know exactly how much money you'd be working with over the course of 5 years. You can find this by using our sum. In this case, we're just summing 5 years. Our first term is 43,800, and our fifth term is 51,600. And then again, we can plug that into a calculator. And get $238,500. Okay, so this stuff isn't necessarily just definitions and equations and not used anywhere else. If you really know how to use this and you're maybe a little bit more responsible with money, um, you can really track how much you're saving, how much you're spending, what you're going to have. There's a lot of different uses for this, and not necessarily just in accounting, right? So this is used in a lot of different places, one of which is probability, which we're trying to get to. Okay, so I'll stop here. This is all I have for you. So your homework is W11 again. I'll leave this open for a couple minutes if you have any questions, either over this example or over anything we've gone over so far. After that, if there are no questions, I'll start a meeting on Teams. And if you have specific questions or just want to work, I will be there. Okay. So general questions here, specific questions a little bit later. All right. So since there are no more questions on this stuff, I will end this. I will be on Teams. And if you have specific questions, I will see you there.